All right, let's dive in head first to number 34 and 16.5. I want to find the volume of the shape that's below Z is R, which is a cone.
Yeah.
Right, that's Z is the square root of x squared plus y squared, right?
Oh. Okay. Yeah.
So of course that's a cone. And then above the xy plane and inside the sphere, x squared plus y squared plus z squared is 8.
Like a pineapple ring.
Like a pineapple ring. Let's see, so I've got a sphere, right?
Yeah.
And I really only care about the top half.
Yep.
And then I've got in there a cone, right?
Yeah.
Where's the cone at again? It's
Well, pineapple
So
ring.
that's Z is
Okay.
R.
okay.
Horrible.
And it says above the X, Y, and inside. Oh.
You guys see that? So I took this stuff out. Oh. You guys all see that? So I've got a sphere with a cone
Okay.
popped out of it,
Yeah.
right? Cool? Check?
Yeah.
Alright. So, thoughts? What's your coordinate system for this?
Yeah.
Spherical, since we're working with the sphere.
Spherical? Does that seem legit? Why would I pick spherical over cylindrical? Why might I think about cylindrical? Oh my god, wait. There's so many systems. This one's already in cylindrical.
Yeah.
Why wouldn't you do cylindrical?
Because we're working with
Okay, good. There's a sphere,
We're
right?
working with multiple angles, aren't we?
So the sphere, right, should definitely suggest spherical. The
Yeah.
cone should definitely suggest cylindrical. How do I know that spherical is a better choice?
Multiple
See the
angles.
cone in the sphere?
Because you're taking the cone out, so the cone doesn't matter, it's what's left after you.
True.
Or below.
Yeah, that's probably a good philosophy.
What? Didn't you
You
say something about like cylindrical doesn't work for...
Cylindrical doesn't do spheres well. Spherical doesn't generally do cylinders well, right?
Yeah,
Then
we don't
wouldn't
have
we
a
just, like,
cylinder,
subtract-
We have mostly a sphere left.
Yeah,
Or half a
removing
sphere.
the cone, we've cut out. We've limited feet.
Good. That's what I wanted. You guys see that?
Eliminated feet.
Taking the cone out really just limits feet. You guys see that? And that's totally fine here, right? That's actually an easy limit for me to express. Spherical also does cones well, because they're just specifications on feet. You guys see that? The other option, right, is that I might think, okay, if I was going to do cylindrical, I'd be talking about where the z's live, right? Like, thetas in here are fine, yeah. Radii are also fine. But it's the z's that would cause me trouble. Because if I picked a point in here, I'd be talking about up to the cone, right?
Which is alright.
Go from 0 to the cone. And then over here, I'd have to go from 0 up to the sphere, so I'd have to split this integral into two pieces. You guys see that? It's not impossible, it's just, I could do it in one if I pick spherical, I have to do two if I do it cylindrical. Cool? So let's do spherical. And we need to figure out our bounds, right? Okay, so I'm going to do a triple integral, right? What am I going to integrate?
Rho squared.
Plus y squared plus z squared.
Well, rho squared, then
Do you want to integrate rho squared?
no.
Why not?
I'm not sure.
Well, we know what rho squared is.
So I have a shape, right, that's described by some functions. I want to find its volume. What's the density that I want to use to find volume?
Oh, rho
One.
squared.
Oh.
The rho squared here, right? That's one of the limits on your integration. You guys see that?
Okay.
you're integrating 3 variables already, right? That's going to give you a volume if you just give it one. Okay, see that? I'm not looking for the area under a curve, right? I'm looking for the volume in a shape.
Okay.
I'm not looking for the volume under a surface, right? We could do it that way, of course, right? With the cone. The sphere would be much harder. So I'm just going to integrate 1 d. Ooh.
Rho squared sine.
Yeah, maybe let me write it this way first.
Oh, shit.
Why don't I say the first thing we're going to do is we're going to integrate 1 over the shape d volume. You guys see that? Then I want you to pick an order. So there's going to be a triple integral, right? Of 1 times something. So you guys said you wanted to try which coordinate system?
Spherical.
Spherical, right?
And
So
then-
what's d volume?
Well, rho
That's a good first
Rho
step.
Rho
squared
squared.
sine phi.
Rho squared sine phi.
T.
Do that.
Oh,
Yeah, pick an order. D.
D.
I'm going to pick an order in a second.
T, right?
Okay, so which things are going to be easy?
Theta.
Theta is going to be pretty chill, right? Because theta is going to go
All around.
all the way around, right? So I may as well do theta
Last.
first, last, doesn't matter. Pick one.
Yeah.
I'm going to throw it in last because I know I've got numbers on the outside then.
Probably Phoebe first.
You want to do phi first?
Yeah, because it's negative.
Okay. So we want to do phi first,
And then row second.
then rho second, of course. Okay. So the phis, they should go from, let's see, so I want to know what that is, right?
Yeah.
Off the z-axis. So what's the tilt for the cone? Z is r.
45.
Probably 45,
Pi
So
over
pi over-
4
pi over
to
4.
3
pi over 4.
Pi over
So I want to
0 to pi over.
0 to pi over 4? Why pi over 4 to pi over 2?
Because
Well,
it's 45 to
skipping
the.
the cone.
Yeah, we're
negative.
skipping the cone, right?
Oh, we're skipping. the
So we
cone.
want to start when the cone ends.
Oh, okay.
So I want the phis, right, to pick up at pi over 4.
Wrong one.
Oops. Phis. Pi over 4. And I want them to stop when I get to,
The
3
flat
pi over
angle.
yeah, flat, right, the xy plane, which is
Pi
Pi
over
over
2.
2.
pi over 2. Because so why, Ken? Why pi over 2 instead of 3 pi over 4?
Well, I
That
was
makes sense.
thinking of another problem where they had us go all the way over to the next, and I think that was just more of a two-dimensional rather than 3.
What would 3 pi over 4 do? How about that? If I swept the phis from pi over 4 to 3 pi over 4. Yeah, it would give me the, right, this thing
Oh.
flipped over. You guys see that?
No, not flipped over. It just it would encompass more. It would let's see. Yeah, kind of like it would consume that whole area,
Yeah, so instead of getting just the top, I would get
top and
the
bottom.
top and the bottom, right? This thing and this thing flipped over.
That looks familiar. Singularity, maybe.
I have no idea. Alright, so we're just doing the top, right? Which is why we end at pi over 2. That's really the equation of the xy plane, right?
Yeah.
You guys see that? And where do your rows go? What's your radius start at?
Starts at 0, doesn't it?
Good.
then square root of 8.
Nice. How'd you get square root of 8?
Because x squared plus y squared plus z squared equals
Z
8,
squared
but there's
two.
no square root.
Perfect. Cool. So, do you guys want to maybe a more algorithmic, less thinky approach to getting those? Okay, so I might write down, what does the xy plane mean? That means phi is pi over 2. What is x squared plus y squared plus z squared? That's
Just row.
that's rho squared is 8, right? What's this first bound? Z is r.
Just a cone.
That's z is
X squared plus y squared.
square root of x squared plus y squared.
Yeah.
Okay. Let's see. What was z in spherical?
Z in spherical.
Rho
Rho
cosine.
cosine.
Is rho cosine phi? What's this thing?
Equals square root of
Square root of
rho sine. Rho squared sine. Rho squared. No, it's just rho. Isn't it? Oh, because you're.
I'm squaring all the bits.
Yeah, okay.
So am I getting this right?
Yeah, cosine squared beta. You're missing a rho squared. But you're. Yeah. But then that just becomes 1 plus 1.
So you need to factor a sine
Oh,
squared
wait.
phi out,
Oh,
right?
no, never mind, sorry.
So what you're going to end up with out of this is rho cos phi is rho sine phi. There's really an absolute value that belongs in here, but I don't care about it because I'm talking about the positive angle.
That's how we get our 45.
And there's your 45, right? That's where sine and cosine cross.
Oh, okay.
You see that?
Yeah.
So did I understand anything about what the hell was happening here? Not really, but I found out that this thing means phi is pi over 4. So I'm going below phi is pi over 4. So that's where the phis are going to start. I'm going above phi is pi over 2. So that's where the phis are going to stop. And I'm going inside rho squared is 8. So that means the rho is going to start at 0 and go to the square root of 8.
Okay.
Then what did they tell me about theta?
Well, just going all around.
Yeah, they told me jack about theta, so I'm going to run theta all the way around. You guys see that?
Yeah.
There's, we could think about this, right? We can draw a nice picture, we can get some intuition, or we can just cram the substitutions in and crank on it. Cram the substitutions in and crank on it is going to be less fun, but it'll give you the right answer in the long run.
Alright.
So here's my setup thing. Should we do that quick?
We don't have to evaluate it.
Good. Let's not evaluate it.
Yeah.